Now we're moving on to maybe a more complicated operation. Before, when we were working with the complement, we were only taking one set, and we were just taking everything that wasn't inside of that set and collecting it into a new one. But now what we're going to be doing is we're going to be taking two sets, and we're going to be using them to create a new set. What we do is, first, I want to create a new set, and I want to create a set J, where J is all the sports teams that are inside of New Jersey. Honestly, all I can think about is the Jersey Devils. I don't really follow anything else. The Jets deserve to be in New Jersey, but they are not, unfortunately. So while I can only dream, what we're going to do is we're going to be talking about the union. A lot of people might have seen the idea of this Venn diagram. This is the one you're probably used to from elementary school, where you have two circles that are overlapping. So say we have our sets N and our sets J. We want to take our union operation, which is N union. It's shaped like a U. That's how you can remember it. J. And what is this? Well, this is equal to the set of, going to put T. It's T such that T is in N or T is in J. And it's going to be T. I put T for teams. And also, it's important to understand that this or can mean both. Now, in this case, a sports team, I should have drawn this a little bit differently. A sports team can't be in both New Jersey and New York. You know what? Actually, I'll leave it. The intersection of these two sets just is nothing. There's nothing in between, in the middle. But sometimes you will have things that are overlapping, and we'll do an example later. But this or, if it's inside of both sets, it's included. So it's what we call an inclusive or. Now the union is just taking everything from this one set, taking everything from this one set, and just creating a big set with everything from both of them. In our case, if we're looking at this Venn diagram, the union is everything inside of both sets. So it's this big overlapping, like figure 8-esque thing. And if we were to list out what's inside of it, it would be all the New York sports teams, like the Jets and the Knicks, for example. But it would also include all the New Jersey teams, such as the Devils, and all the other teams as well. With all of that, we now have our union. It's just you take two sets and you combine them into one. Now let's talk about the intersection. The intersection, it's the same as before, in which we took two sets and we did something to them in order to create a new set. So before, what we did was we took everything from both of the sets and we just made it into one big set. But now we're going to refine it, and we're going to make it so that we take the two sets and we're going to make them smaller. So the intersection is kind of the opposite of the union. What better of a symbol? Just an upside down union symbol. It's kind of cheesy, but it works. Now for this example, we're going to be taking our set F, which is all football teams, and we're going to be taking our set N, which is all New York sports teams, and we're going to be intersecting them. And what does this mean? It's going to be T, such that T in F and T in N. And this is a very important and. Well, this means we're creating a new set that has all the items of F and N that are inside both of them. So if we're looking at our Venn diagram, it's this shaded region right here. So this region is inside of N, but this region is also inside of F. So because of that, we say it's in our intersection. It's where these two circles intersect or overlap. So for our example, try to do this yourself. I would say pause the video about here. What is the intersection of all New York teams and all football teams? What items are inside of both of these sets? Well, what's inside of both sets? It's just the New York football teams. So that would be New York City football teams, I should be specific. That would be Giants and the Jets. Right? That's the intersection. Because the Giants and the Jets, they're both New York City football team, or they're both New York City sports teams, so they're in N. And the Giants and the Jets are also football teams. So they're inside F as well. And that's our intersection. Moving on to our next operation, we have set differences. So before, when we had set unions, we could think of them almost as adding two sets. You take two sets and you condense them into one singular one that has both of the things inside of them. And it's like you're adding them together. It's like a joint collection. But what happens if you want to subtract two sets? What's the difference of two sets? Well, we have a thing for that, and it's called the set difference. Now, there are two different notations for set difference. So there is, some people write it F minus N, but my preferred notation, and this is the one I use when I'm doing set differences, is F backslash N. Why? Because minus sometimes means other things. So when working with sets, I use the backslash notation. But if you find F minus N to be better and less confusing, by all means, go for it. When taking the difference, what do we want? We want our set, if we want our set of football teams minus all of the New York City sports teams, well, we want all the football teams such that, you know, T is a football team, and we also want it so that T is not a New York City football team. This sometimes will trip some people up. So it's anything in F, anything in F that is not inside of N. If you're thinking about it, you're almost taking things from F, and when they appear inside of N, you're erasing them out. And you're subtracting them and removing them from your set. So from our Venn diagram form, if we were looking at this like this is our set N. This is the intersection of the two. And we have everything except the intersection of F. So we're just kind of subtracting this little area off. So what would be this set? What is F minus N, or the difference between the two? Well, it's going to be all football teams that are not New York City football teams. So this will be the Rams. This will be, I almost said the Hawks, but I meant the Falcons, etc., etc. And the Jets and Giants will not appear. So this is not going to contain the Jets and the Giants. And that's the set difference. Now, before we move on to our final operation, and probably the most confusing of all of them, we're going to add a little addendum to our difference and talk about another operation that's not as frequently used, so you may not see it as often in your classes as the other ones, but it's still worth mentioning, and it's called the symmetric difference. So the symmetric difference is notated this way. It's F triangle N, and there's a couple ways you could define it. We're going to define it using other operations, but the way it works is it's going to be everything inside of N, F that is not inside of N, so the difference that we just went over, and we're going to union that with everything inside of N that is not inside of F. Now, this might look a little scary. Another way we can write it is it's the union of F and N minus the intersection of F and N. So why is this called the symmetric difference? From this notation, it might be a little clearer, but if we were to take the union, it's everything inside of this whole area, but we're removing the intersected part, so we're removing this little center part. So from a Venn diagram perspective, this is the symmetric difference of F and N. It's this whole thing minus this little center bit right there. Now, just to explain what this would mean, what would this symmetric difference be? Well, it would be all the football teams, so it would be like, you know, the Rams, it would be the Falcons, but it would also be all the New York City sports teams, such as the Rangers and the Knicks and etc. And it would be all of those things, but it would not include their intersections. So it would be all of the NFL football teams all of the New York City sports teams except the Jets and the Giants. The Jets and the Giants are not included inside of this set. And with that, we can move on to our final operation.